Hello, my name is Shoham. I'm VP Technology at Beamer, and I'll be talking today about the why and how of subjective video quality assessment. Before I start, I would like to express my deep gratitude to the Mile High Video organizers who have put together an amazing event despite the challenging times we find ourselves in. I would also like to thank you for this opportunity to share my views and my work on this topic of subjective video quality assessment. So what will we cover in this talk? We'll start by discussing why subjective video quality evaluation is important. We'll take a look at video applications and their goal, and the pros and cons of objective measures. We will then talk about how to perform subjective video quality evaluation in a rigorous fashion, pragmatically, and we'll touch on Vista, an application we developed for internal use for subjective video quality evaluation. Looking at video applications, in the past, life was quite simple. Content was created either in the studio or by recording sports games or venues, and the viewing experience was relatively passive and laid back. Nowadays, we see that content creation has become very diverse. While we still have content that's created in the studios or in sports game, there are many platforms for creating content, such as gaming, automatic creation of content using various animation and graphic applications, or user-generated content. The viewing experience has also become much more interactive, much more integrated, where the content creation and viewing experience may be actually performed in a closed loop, and viewing is performed on much more diverse platforms and environments. What does the future hold? Well, we can only guess, but we see an increase in demand for high quality, high value content, where the increased quality is reflected in higher bit depths, higher resolution, be it temporal or spatial, higher bit rates. There is a lot of content, explosive amounts of UGC, not unrelated to the phenomena of cameras everywhere. What do we predict for the viewer? Well, as I said, we're seeing more and more demands for high quality and for high accessibility. Even though there are amazing advances in AI viewers, for the foreseeable future it's expected that the human will still be in the loop and still be the primary consumer of the video content. To summarize, we see that people are consuming more and more video, and their demand for quality is constantly on the rise. The goal we face as engineers working in the domain of video streaming, video compression, and creating good video workflows is to provide video that has high perceived or subjective quality. Objective measures can also assist in evaluating visual quality. These measures can be split into three categories of no reference, reduced reference, and full reference. The different metrics are useful in different target applications, and different metrics may be more or less reliable in specific dynamic ranges. Looking at a multidimensional space that is spanned by axes, describing different properties of the quality measure, each quality measure will have its own coordinates in this space. For example, some metrics are very simple, while others are more and more complex. Some metrics are purely image-based, while others incorporate temporal models of varying levels of sophistication. Overall, the metrics go from the simplest, such as PSNR, which used to be widely used, to the more advanced metrics that we're seeing being incorporated in more and more products and workflows, such as the quality measure we use at Beamer, VMAF developed by Netflix, or the improvement on it suggested by Fast Video. Why are objective measures useful? Well, They are the simplest way of getting feedback on video quality. The results can be reproduced in different labs or at different time spans for the same data. They allow extensive evaluations by performing many encodes or processing of video data using different configurations, different target bit rates, different codecs, creating BD rate curves and comparing them to evaluate the workflow quality. These metrics are constantly improving and they are getting more and more correlated with actual perceived quality. While it used to be a concern that some of the more sophisticated metrics have high computational complexity, at least in some applications and with the increase in computing power, this is less of a concern in some cases. A huge advantage of objective measures, and one that we utilize at Beamer, is that they can be introduced inside the video processing or video encoding loop and used to improve encoders or create sophisticated content adaptive encoding solutions. Well, if objective measures are so great, why don't we just use them exclusively? There are a few reasons. Existing metrics can be easily fooled or overlook subjective quality loss that was introduced but is not modeled successfully by the objective measure. As we have a short time here, I will not go into detail, but if you haven't heard it yet, I highly recommend Richard Fleam's talk from DMAX last year about objectionable uses of objective video quality measures. Metrics often don't adapt well across different applications, different content types, or when used with different codecs or processing types or different video workflows. We are seeing a lot of use of machine learning, even deep learning-based approaches to calculate an objective quality measure. These are great, and there are some very interesting advances to be seen in the research, but there are a few inherent problems. The first is that there is no way to reliably rank the human perception or subjective quality opinion at a frame level when viewed in motion. So what is actually performed is we take short segments of video and receive a human ranking on that, and then use this as a ground truth to train a per frame video metric. Creating these ground truths is also quite expensive and time consuming, so there is limited availability of these databases. But even more concerning, in my opinion, is the accuracy of the ground truth that we use in training. To demonstrate the accuracy problem, here's an example taken from work cited here to create a large-scale video quality database for ultra-high definition content. The graph shows the MOS scores for the same files when included in two separate testing rounds. As you can see here, we have points that raise some concern. This point, where in one test round it received 4.5 and in another 4.0. These that received a score of 4 in one test round, but only 3.5 in another. Here we have a clip that was ranked once as almost 3, while in another test it was only slightly over 2. These inaccuracies mean that our ground truth has a deviation of at least 0.5 and probably more, and this is the maximum accuracy that we can hope to train for. So, to summarize, objective measures are great, and we're seeing fascinating advances in calculating them, and for some cases, they are irreplaceable and should definitely be used. However, they are limited, they do not always reliably measure perceived quality, and therefore should not be used blindly or exclusively to measure subjective quality. So, hopefully I've convinced you that measuring subjective video quality is important, but how do we go about it? Well, the gold standard is ITU-BT 500. But as anyone who has tried doing it can testify, you end up feeling a bit like this guy here clutching his head. It's expensive, it's time consuming, and I think one of the large problems is that it doesn't correspond to true video viewing conditions. If you know anyone that creates the exact correct lighting ambience, measures the distance between the screen to where he's sitting, and paints the living room wall gray before he starts viewing, well, I sure don't. This has been recognized, and the newer standards created by ITUT relax some of the constraints and take a step toward the pragmatic evaluation that I will describe next. So how do we go about pragmatic subjective video quality evaluation? We want to use diverse and flexible viewing conditions. We want to have many participants, but we do need some screening methodology so we know that our statistics will be reliable. We are happy to see that more and more companies are setting up subjective testing platforms, though Corona has hit us there too. MSU, Moscow State University, renowned for their work in video compression and video encoding evaluation, also launched a utility called Subjectify.us, where you can upload images or videos that you want compared, and they perform crowdsourcing and statistical analysis. In the remainder of this talk, I will present Vista, a visual subjective testing application that we have developed internally to use for subjective video evaluation on our products and research projects. Vista consists of a client and server, where the client is an application that supports side-by-side comparison. In developing it, we focused on making it user-friendly so that the only things that are required are viewing and selecting a relative quality. We use forced choice double stimulus because it is well suited to assessing visibility thresholds, which is one of the tasks we are heavily focused on. We validate or verify users using what we call validation pairs. So what does the client look like? You download an application and launch it. You are then requested to submit an email or a worker ID. Then, all the files that will be used during the viewing session are downloaded in advance to avoid any issues related to buffering or connectivity issues that are not the focus of our testing. Then, there are instructions on how the test is to be performed. And the test starts. During the test, 2 video clips are played synchronously side by side. When these complete, the user will be able to select which appear to have lower quality, the clip on the left or the right, or they may choose to replay the videos if they have not yet made up their mind. Generally, we use up to 3 types of video clip pairs in our testing. The first type, and the majority of the pairs shown, are the target pairs that are related to the actual test we are performing. For example, if we want to verify that an optimized set of files with a reduced bitrate is perceptually identical to the original pre-optimization files, each pair of target pairs will consist of a corresponding reference and optimized segment. For user validation, we create pairs where one clip has a visible degradation compared to the other, not something that is blindingly obvious, but something that is visible. We use these pairs to make sure that a user is paying attention and not providing random answers. Only users that get these answers right will be included in that statistical analysis. A third type of pairs are those used for statistical validation, where we actually just show the same video on both sides, and we use this, for example, to see how many cases or clips or users we need in order to reach a certain level of statistical certainty. Once all the pairs have been viewed and ranked, the user will receive a confirmation token, which is what he will provide in turn in order to be paid for his task. The other part of Vista is the server, which is used to create, control, and analyze the test sessions. We need to carefully equalize the selections of the video pairs that are used so that we will have good statistical coverage of the different target comparisons. The order of viewing, left versus right, e.g. the positioning of the videos when viewed, is of course semi-randomized. The reason it's not completely random is we do not want to create very long sequences where the graded is shown on the same size, reducing the viewer alertness. To make our life even easier, or in the spirit of the proverb, laziness is a good incentive for invention, we also developed AutoVista, which we described in the paper cited here that was presented at SPIE last year. In the heart of the system, we see the Vista client and the Vista server I just described. We use a crowdsourced testing platform, specifically Amazon Mechanical Turk, to recruit a large number of workers and perform these test sessions. We also automated the session creation, e.g. the encoding processes of the clips, creating the database entries that are required for the Vista server in order to create test sessions, and automated the result collection and analysis. This enables us to go from a question such as, is a set of encoding A perceptually identical to a set of encodes B? Or is a set of encodes A visibly better than a set of encodes B? To the answer almost fully automatically. So what are the key takeaways? Hopefully, even if you didn't think so before, I've convinced you that humans are still the primary video viewers, and the subjective quality is therefore what we need to target in our video workflows. The awareness and demand for video quality is constantly increasing, and consumers are becoming more and more aware of the video quality. While objective metrics definitely have their place in video development and research, they should not and cannot be used exclusively or blindly as the only indication of video quality. On the other hand, fortunately, pragmatic subjective evaluation is an option that is both practical and affordable, and there are ways to receive reliable subjective video quality evaluation on a large scale, efficiently, quickly, and without spending too much money. Thank you so much for your attention, and I'll be very happy to answer questions, be it through the conference venues or directly at the email mentioned below.